Very good morning to all of you students. Welcome to the mathematics class. In this session, we will study a most important chapter of your syllabus and the name of that chapter is real number. So student, in this chapter first of all we will discuss the basic definitions. So the definitions are first natural number. Natural number is represented by capital N and these are the counting numbers. That means we are used in the counting. For example, 1, 2, 3, 4, and so on. And the next number is whole number. Whole number is represented by W and it is starting from 0 and all the counting numbers are including to it. The next number is integers. Integers are represented by capital Z. They are positive integers and also negative integers. So, all the numbers with positive and negative signs are considered as integers. The note point is here 0 is neither positive nor negative integer. Now student, the next topic is rational number. Rational numbers are represented by capital Q and that number which can be written in the form of P by Q where Q is not equals to 0 and there is no common except 1 between P and Q, then these numbers are said to be rational number. For example, all the numbers which can be written in the form of P by Q, we can say that they are rational number. For example, 1 upon 2, 3 by 4, 4, 5, 6, 7, etc. Now the next number is irrational number. Irrational numbers are generally represented by capital I and those numbers which cannot be written in the form of P by Q where P and Q should be integers, they are called irrational number. For example, root 2, root 3, root 4, pi, etc. Now student, we will discuss here the representation of integers on a number line. We can represent any integer on the number line according to the given diagram. In the diagram you can see that all the numbers can be represented according to the number line. Now student, we will discuss here the most important example. We can find any number of rational number between any two rational number. For example, find 9 rational number between 0 and 0.1. So there is a formula by which we can find the number of rational numbers and the formula is d is equal to y minus x upon n plus 1 where n is the total number and x is the first number, y is the second number. So with the help of this formula we can find the gap and after that we will add this gap is first number will get we get the consecutive rational number. For example, here on putting the values we get d is equal to 0.01. So on adding 0.01 in the first number we get first rational number x plus t means 0.01 and after that x plus 2d the second rational number, after that x plus 3d the third rational number. In the same way we can find the number of any number of rational number between any two rational numbers. Now student, there is exercise 1.1. So you can solve all the questions of this exercise on the above basis and if you understand all the descriptions which is given by me, so you can solve easily this exercise. So this is your homework to solve all the questions of this exercise. Now student, we will discuss here the next important topic, terminating and recurring decimal expansion. So first of all I want to introduce what is the meaning of terminating and recurring decimals. Terminating means a number which can be terminate, that means it will be end after some places, after some digits, and recurring means which cannot be terminate, that means it will be continuation, it will be flow in the continuation after the decimal. So I am telling you by giving some examples. So the first example is 1 upon 4. 1 upon 4 means the decimal representation is 0.25. That means it will be terminating because it will be terminate after two digit of the decimal. That means it will be considered as a terminating decimal expansion. Now we discuss here another example, 0.99999. So it is an example of a recurring decimal expansion because here the numbers are flowing in continuation. That means there is no termination. That means it will be considered as a recurring decimal expansion. So student, there is second exercise 1.1, 1.2, and these are the questions which are related to the above explanation. So you can also solve these exercise in the basis of above explanation. Now student, we will discuss here irrational numbers. As above, we also discussed the meaning of irrational number, means those numbers which cannot be represented in the form of p by q, they are called irrational numbers. And here there are some examples. For example, 0.01 double 01 triple 01 fourth 01. That means it is an example of irrational number, and they are non-terminating and non-recurring. Student, there is another exercise number 1.3, and in this exercise you can solve the questions related to irrational number. So you can also solve this exercise very easily with the help of these examples and the above description. Now student, we will discuss here real number. Real number is the most important topic in this chapter, and real numbers are a number whose square is non-negative. That means if we square any number, then the value should be in positive. It's called a real number. In fact, all rational and irrational numbers from the collection of all the numbers are considered as a real number, and they should be rational or irrational numbers. Now student, there is another exercise 1.4, and in this exercise we will solve simply the multiplication, addition, subtraction of any two rational numbers. And in this exercise you can add the rational number or irrational number very easily way. So you should solve this exercise, and you will use the examples for solving the exercise. Now student, we will discuss here rationalization of any rational number or irrational number. So what is the meaning of rationalization? So the meaning of this word is, if any number is given in the form of p by q, so we can multiply and divide by the denominator number, and if the denominator number in the single form, then you directly multiply and divide by the square root number which is given in the denominator form. Okay. Student, we will discuss here an example. Simplify 3 upon under root 5 by rationalization the denominator. Here denominator is root 5. It means that we will multiply and divide by the root 5, and after multiplication and division we get 3 upon root 5 is equal to 3 upon root 5 into root 5 into root 5. That means 3 root 5 upon 5. So it is the required rationalization form of the 3 upon root 5. Now we will discuss here rationalization factor. Rationalization factor is those that number which will be multiply and divide for getting the number in the simplest form is called rationalization factor. So it's a student, you can solve the exercise 1.5 for using the above examples and by the above description. So you can solve all the questions, and these questions are very simple, and you can multiply and divide by the denominator term. Now student, we will discuss here the most important topic, and this topic is related to the another chapter, for example logarithm and some chapters. So this is very important formula for the exponent also, and the formula is, if there are two numbers in the multiplication which have the same base, so after multiplication we will write the base in one time and the powers will be add. That means a to the power m into a to the power n is equal to a to the power m plus n. In the same way, if two numbers are in the division form but their bases are same and powers are different, then we will write a to the power m minus n. If any number is written in the form of power and there is another power, so the both power will be in multiplication. That means if a to the power m whole power n is given, then we can write a to the power m into a to the power n, and a to the power m we can write a to the power 1 upon a to the power minus m. If any number have the power as a 0, then its value will be 1, and if two numbers are in the multiplication have different bases and different power, different bases, but the power is same, then we will write it bases are in the multiplication and power should be in one times. So student, you can solve the examples of above questions, and you can also solve the exercise on the basis of above description and above lecture. So there is exercise 1.6, and in this exercise all the questions are related to the exponents. So by using the properties, by using the laws of exponents, you can solve easily this exercise. And student, this is your homework to solve all the exercise very carefully and read all the important instructions, all the important definitions. So after reading the definitions, after understanding the process, you can solve this exercise very easily. So student, keep watching the videos and do all the questions very well. Thank you very much.